Security is critical for connected devices. One of the ways DornerWorks engineers incorporate security is right from the beginning with a process called Security by Design. In this interview, we'll be talking to DornerWorks Technology Strategy Leader Dan Rittersdorf and IoT engineer Ray Smith. What are the basic principles of security by design?
I like to look at a few different points. The first thing that I'd like to do is to know where the money comes from for a customer, what their business proposition is. Because if you know how they make their money or what's important to them, you know what to protect at its core. Before you design anything for them, you know that what you do can't affect their core business. Then I'd like to know what specific things potentially could devalue their business proposition. Things like loss of revenue, loss of customer data, loss of reputation, loss of control of their data or their networks. Those types of things are important. The next thing I'd like to do is to get to know what it is they want us to design, what they want their device to do, how their user needs to use that device, the life cycle of the device, what to do at the end of its life, things like that. After that, I want to know what data needs to be handled, what data is passing through the device, what data is being associated with the end user of that device, things like that. And then I can classify that data as far as what's important, what needs to be protected, where it needs to be encrypted, things like that. Then I can use best practices for creating an architecture for how that device interacts with the user, with the customer's corporate networks, or their end user networks and things like that. And then I can protect the data, and then I can protect the architecture. A couple things I definitely don't want to forget include the ability to integrate testing at all critical points in the architecture and on the device to make sure that, one, everything functions the way it's intended, and two, that we catch any corner cases that might not have been thought of before. Independent testing is best. That way it's not the same people who are making the design seeing things as they designed it or as it should work. Someone from outside can have a better perspective on where some of those gotchas might be sitting. And then starting testing early and often, as soon as basic functionality is available. I got that one from Dan. And then the last point is, I think it's important to design and test security incident response. Whether it's on the device or in the cloud, you want to be able to detect when something goes wrong, when someone is accessing a device in a way that's not designed, when it's not designed for. You want to be able to detect those incidents and to respond to those incidents to minimize the amount of damage that can occur. So with those principles, I think starting from the very beginning, that puts you in a pretty good standing for designing security from the very beginning.
What security risks do these principles help you mitigate?
Okay, one that I like coming to frequently is in 2015, Jeep Cherokee was accessed remotely through the entertainment system. And through that, the remote actor was able to control other aspects of the vehicle. The reason why that ends up being significant is the communications protocols within the vehicle were old and not designed for security from the very beginning. It was just not needed at the time it was designed. And these newer systems are built on top of those those communications protocols, and the lack of security within that entertainment system allowed that user or that remote actor to access that communication and start controlling other parts of the vehicle, particularly critical vehicle functions like steering and braking and driving functions. Other security risks that have been in the public eye recently include LastPass being compromised recently, and then some internal developer account was compromised, and it led to source code being leaked, which may contain secret sauce for LastPass or any other proprietary information. One more example: recently, Google fixed a flaw that was found in the fingerprint sensor of one of their phones, and that fingerprint sensor was allowing unauthorized fingerprints to unlock a device. That has since been patched, but the failure happened likely due to some testing not being able to catch that before it went out in public. So having security principles by design from the very beginning, catching all of those different cases would have likely prevented each of those different incidents.
What security risks do medical devices face?
Well, medical products face many of the same security risks that commercial connected devices have, but the close relationship to personal health and well-being, coupled with the regulated nature of the market, it makes the security landscape a little rockier for medical devices. Add to that the history of medical devices not including security by design, but having it added on to legacy products later. That leaves the medical device manufacturer open to vulnerabilities that they would otherwise not have been open to. A security breach related to a medical device can endanger the health and well-being of a patient, the device operator, or other patients in the same hospital, depending on the depth and breadth of the breach. So, one of the things that we need to be concerned about in designing a medical product from the beginning is to protect privacy. Medical devices often require access to closely held personal information, private personal data that, if it were made public, may be embarrassing to the patient or may reveal information that could be used to damage them financially or in some other way. So names and addresses, financial data, these types of data are a treasure trove for the bad actor, and actors will pay more, or clients will pay more for medical information than they will for standard financial data. So that makes medical devices particularly tasty. And medical device manufacturers are required to protect that data. The consequences of failure can be costly. HIPAA law in the United States and privacy laws in the EU are even stricter. These are examples of laws that require the protection of private data. Another function, another worry about security of medical devices is to provide patient safety and security. We talked about the fact that the patient may be harmed by a cybersecurity breach. A bad actor may affect more than one patient even. It might be one thing to hack a pacemaker and threaten the life of an individual, but if that pacemaker is connected to a network, or that other medical device that was compromised is connected to a hospital network, the breach of a single device can be a vector to a larger breach of the hospital's network. And that can endanger the health and well-being of all the patients at the hospital. For example, we've heard of multiple incidents of ransomware taking down hospital computers so that nurses then have to go back to recording patient data on paper and pencil as opposed to in their computer records. And how does that data then get synced back into the electronic medical record? So that's a potential danger. Examples of known breaches through medical devices include pacemakers. A major medical device manufacturer's pacemaker were found to have a vulnerability that could be used to potentially kill a patient, modifying the heart rate. Drug infusion pumps. Another manufacturer's pump was found to have multiple vulnerabilities and could be used to modify the function of the pump. And that could include the potential for a fatal drug overdose. And another example, MRI system was found to have a vulnerable Windows installation on it in one of the components. It was used for a common ransomware attack, preventing the MRI from functioning. And there's an example of lab analysis tools being used to compromise the lab analysis tool, and then the attacker tried to gain access to the hospital's network. Now, in that case, fortunately, the IT department had thought ahead, and they were ready for an attack. And so they were able to fend off that greater attack. So that's an example of where planning ahead and looking at possible vectors of attack, we're able to secure a portion of the hospital. But that attacker should never have compromised the medical device in the first place. And then finally, medical devices need to protect IP. That's not unique to a medical device, but the medical device manufacturer has a greater cost invested in a medical device than a commercial device because of the regulatory burden that comes with making sure you have a safe and effective device. Medical devices are more costly to make. So when it's compromised, the cost to the manufacturer is higher. So you want to do things to protect your software in the medical device. You want to protect the hardware design of the medical device. Devices may have functionality that's password protected. Using a static password to access maintenance capabilities is a common way that medical devices are compromised. And then, if they had used a more secure password method or encryption method to authenticate the user, then that compromise would not have occurred. So no static passwords, because once you've leaked one, all of those devices are compromised. Medical devices developers like DornerWorks need to lock out physical access channels, unused USB ports, SD card readers, and debug interfaces on the hardware. These are ways that somebody may get access to the device physically and compromise the device, gain access to your firmware. We need to provide encrypted, authenticated connections from the outside world. When a device needs to talk to the outside world, that needs to be secured in a way that we authenticate. Is that user authorized to talk to me? We need to provide protection against software version rollback, because if that's a possibility, then an attacker could roll back to a compromised version of the software and gain access to a device that way. We need to make sure that new software updates are authorized updates, that they are from the correct provider, so they need to be signed updates. And the channel for communicating that software needs to be authenticated using a secure root of trust. And we need to guard against physical intrusion or side channel attacks based on power use or time to authenticate. These are ways that can reveal whether you've got a greater chance of breaching the device as you try to attack it.
How do we apply security by design to medical products?
Well, DornerWorks begins with the initial steps of the design, much like Ray already talked about. Once we have the requirements for the product, we perform both safety and security risk analysis. We look closely at the product for flaws at the interfaces, vulnerabilities in the electronics, in the interconnects of the components, the peripherals. We estimate the risks associated with the vulnerabilities. Once we've identified vulnerabilities, we score those risks. The ones with the highest risks are mitigated with hardware, software, or documentation and labeling mitigations. Now, obviously, a labeling mitigation is the weakest of those. A hardware mitigation can be very, very strong. Totally prevent the vulnerability from occurring because you've made a change in the hardware. But software vulnerability mitigations are also done. These are recorded as requirements in the requirements for the tool. So it iterates back to the requirements, and these risk requirements then become a part of the definition of the product. So we continue to evaluate the electrical design, the software design, the architecture of the design, the code throughout the development of the process, analyzing the code for vulnerabilities, looking at the third-party components we're including and looking at the vulnerabilities that they may include. The software bill of materials defines everything that is part of your software, including third-party software, what the standards call SOUP. These third-party software components are a source of vulnerability, not only as we do the development, but can be a source of vulnerability as the product goes into production. We need to be aware of what's in the software so we can guard against the future. As the product comes to life, we perform testing to ensure that the device holds up against attempts to attack. Ray mentioned, I'm a proponent of getting testing in early and often, and with people who aren't the developers of the software. So often when we test something and we know how it works, that dependence leads to a blindness that allows us to not see what really is going on. We like to see it work. We don't want to see it fail, and that bias bites us. So an independent tester is very important. And as the product comes to life and goes into production, we perform testing to ensure that the device holds up against attempts to attack. In the medical device community, we're required, or manufacturers are required, to perform post-market monitoring. So even when the device is out in the market, they continue to look at what vulnerabilities could be in the software, what new vulnerabilities are showing up. And so that goes back into the process, feeds into new requirements, new risk analysis, new risk requirements, and gets turned into software patches that then must be deployed in the market. And that goes on for the whole life cycle of the device. In fact, the device is eventually going to be shut down one day and may contain personal and private information. From day one, as you're designing in those requirements, we need to be planning for the last day so that that device can be cleaned up and disposed of in a proper manner. Protecting the patient, protecting the hospital, protecting everybody who's come in contact with it.
Ray and Dan, any final thoughts on security by design?
Between what I mentioned as far as the basic principles and some of those practical steps Dan mentioned, I think they're absolutely important. You definitely want somebody helping you walk through that, somebody who is aware of all those steps, someone like Dan.
Thank you, Ray. Medical devices are my specialty. They're used in homes, in hospitals, in clinics, everywhere. The environment that the medical device is something we don't know. From concept to production to deployment to end of life, the medical device manufacturer and the developers like DornerWorks need to be on top of the cybersecurity life cycle and looking out for the attacks that are not only possible today, but those that might be possible in the future, and responding in a timely manner when events do occur. We need a pre-planned response designed in from the beginning as to how we're going to respond if a vulnerability becomes an exploit. As a medical device manufacturer, whether connected or standalone devices, SAMD or SIMD, software as a medical device or in a medical device, you need a device developer that understands your challenges, is ready to help you meet those challenges with processes and skills that are based on industry standards and practical good sense. DornerWorks is here to help reduce regulatory troubles, including those that come with cybersecurity preparedness.